Hello, welcome. So this presentation is about Verdigris, and that's Verdigris is a replacement of mock. And so first, the goal of my presentation is mostly about presenting what mock does and how then we can replace it. So first, let's start. For those who do not know me, let's start to talk about me. So I started to know Qt as a student, working for QtDay, contributing to QtDay rather, which led me later to be hired by Trolltech in 2007, working on Qt. I've been then working on many areas of Qt. I've been maintaining item views, the graphic scene, and also QObject. And so I'm the one who wrote the new connection syntax in Qt 5. But since 2011, now I'm working for Wobox, so I'm doing some contract work. I can help you fixing feature in Qt or fixing bugs or things like that. At me, I also have a code browser if you know about it. So let's talk about mock. So when you compile Qt, when you compile your application and you look at the output, and sometimes you see mock is run, but what does mock do? So here is a typical Qt class. You inherit from some class which itself inherits from QObject. You had a few macros, a couple of properties, some signals, some slots. I guess you're mostly familiar with this, so I don't have to go into details on what everything does here. We're in a Qt conference after all, but the question is how can this work behind the scene? So in one of the most significant feature of Qt, I would think, is the signals and slots. And already since Qt 1, and it's still working today, you can use this syntax with those macros, signal and slots, which actually will convert their arguments into string. And so you can emit the signal, and it will call the slot. And since Qt 5 now, there is a new syntax with function pointers. But why do we need mock for that? So we need mock because, first of all, we need to implement the signal. So the signal is just a function, but who implements this function? Well, it's the mock. The mock will generate the code for the signal. The mock will also generate the code, which will allow to get from a string. So this string you pass to the connect macro. So name changed is a string, and we will get an index from that. So the index of the slot or the index of the signal. And that's again what the generated code by mock allows. Even for the new function pointer syntax, it's not really new anymore, but even for this, we still need mock to get an index from a function pointer for a signal. And also, in order to invoke this slot. So given an index of a slot, we can invoke it. It's QMetaObject invoke. No, sorry, Qmeta method invoke. And QMetaObject invoke as well. And so it calls the function, given a string or given an ID, it calls the right function. And the other things that mock enables is properties. And properties, they were first introduced to help with Qt Designer. So in Qt Designer, which you use to develop a widget application, you have all the properties right there in this property editor. And when you have enums, you can select which value of the enums. And this is all done thanks to this information that the mock provides as the reflection system. So Qt Designer knows what to do or which properties every object has, and how to set it, how to read it. And this property system can also be used from QtScript. So in QtScript, you can expose, so we can expose our widget from before, and then we can query the name, call signal, call slot to it, connect to signal, read and write properties. And so we can access all the properties that are accessible from C++, we can access it from QtScript. QtScript was introduced in Qt 4.2, and now it's another things that uses those properties and use those signals and slots is QtDbus, which allows to connect to signal or to call function from other processes. And finally, QML, which replaces QtScript now, and you all know QML as well. We can again access properties, access call invocable method from string, all of that thanks to the information that mock provides. But so how does it all work? How can we get that to work? So the mock will take your C++ header, so that's the file we saw earlier with all those macros, and it will just read all the properties and all the signals and slots, but it will not care about anything that is inside the bodies of the functions. So it will just get the class layout, and from that, it will generate this reflection information in a separate file, this mock file, which is, again, a C++ file, which is going to be compiled with your code. So we are going to read your code, and we're going to generate more code, and then the compiler will take your code and the additional code together and create your program. So all those macros we saw, they're just plain C++ macros, nothing magic. They can be a bit complicated, but let's try to see what they actually does. So here is what you write QObject. Here is a slightly simplified version of the macro, so it fits on the slides. But what it does, it creates, it declares a few virtual functions, which are, so it's inherited from QObject. And it also declares a static meta-object inside the class. And all of this will be implemented by mock. So mock will generate the code of those functions in the C++ file. Most of the other macros are very simple and mostly expands to nothing. So slots expands to nothing. So when you write public slot, it just means public. So for the C++ compiler, slots are just normal function. For the C++ compiler, signals are public function because signals is public. It used to be protected in Qt 4, but in Qt 5 now it's public because you need to access the address for the new connection syntax. And the other macros, QProperty, QInvocable, and so on, they're defined to nothing. Even emit is just syntactic sugar, it's also nothing. The mock do not even see this macro because it's in the body of the function, which we see is not, mock doesn't care about it. And the slot and signal macro in uppercase, they're converting their arguments to string so that the runtime, the Qt, can take the string and get from the generated code the index of the signal or the slot. Who knows about QGadget? So very few people, considering how useful this macro can be. So QGadget is a bit like so when you expose your object in QML, if it's a QObject, it's a bit heavy. You allocate it on the heap, and it has all those internals memory-wise. But sometimes you just want a point, say QPoint, with just X and Y. And you can still have properties on those objects, so you just don't inherit from anything. You say QGadget, and the mock will generate information for it. So that allows to have properties on or invocable method on very simple class that you usually just copy around, and that can be exposed with QML. And so QGadget is just like, it's pretty much quite simplified version of QObject, which still has a static MetaObject, but do not have any virtual function. So when you want, but you can still expose it through QML because the meta-type system knows about it. And the other macro here in this slide is QEnum, which allow to easily, when you want to debug an enumeration, QDebug and then the value and then some enumeration, then it will print on the console what it is actually, which enum value it is in strings. And so in order to do that, we have some friend function here, so we can get from the type to the meta object. This is a bit complicated, but I've written a blog post about that. You can look it up on my website if you're interested. But the way we know all the strings is because, again, it's part of the information that mock generates. So the QMetaObject, it is just a class with a few members. So these slides do not show any of the public function. I'm interested here in the private functions, or rather the private members. And we basically have a pointer to the base object. So if we inherit from, say, QObject, we would have a pointer to the QMetaObject of QObject. We also have an array of strings. So this is all the strings that are part of this meta of information. They're in a Q-byte array data. And so Q-byte array data is basically, Q-byte array is just a pointer to a Q-byte array data. And Q-byte array is implicitly shared, so Q-byte array data has a reference count, but in this case, the reference count is -1, saying no need to free this memory because it's going to be allocated in the code. So it's static data. And so we have an array of Q-byte array, and we have also an array of integer. And this is the actual data which we need to, so we know, we'll see later what exactly this data contains, but it contains all the information needed to reconstruct, to know how many signals we have, what are their names, and such. And finally, we have a function, a pointer to a function. So it's a pointer to the static meta call, which is a pointer to the generated code that contains the code that calls signals and slots. And so the code generated by mock, we tried our best so that we have no static initializations. So that means that we don't have global object with constructor, so there is no code that is run when you start your application to initialize the meta object. All the meta object exists in the static read-only data of the executable. So that makes it really fast to load libraries made with Qt or the code. And we also try to avoid any compilation warnings, so it plays well with static analyzer or anything, or if it doesn't, it's a bug and you should report that. But the goal is not to get in the way of existing tools, and everything is just C++, and all the tools like debuggers and other things, they should just work out of the box. In an ideal world, of course, there are some problems. There is always some bugs, but normally this So this is bugs and it should be reported. So I've been talking a lot, but let's have a look at exactly the code. So code is worth more than many words. So here's the code generated for the signal. So here is the signal number 0. So what it's going to do, it's going to call QMetaObject activate, and it's going to pass as parameter which object it is, so this, a pointer to the static MetaObject, the ID of the signal, so in this case is the first signal, so the 0 is first, and an array of pointer to the arguments. So in this case we have one argument, it's a string. This string lives on the stack. We're going to pass a pointer to this string which is on the stack in an array. And here so the value 0 for this array would be a pointer to the return value. In this case, since there is no return value, it's a null pointer. It's a null pointer. If there was a return value, we would instantiate the return value here, and we would pass a pointer to this return value there, which we will then return. Yes, indeed, signals can return value. This is not very much used, but this is the case. So yes, so the signal will just pass an array of, we'll just call activate with an array of the arguments. And then the QObject runtime will take care of calling the right slots that are connected to this signal. And how do we call a slot? Well, if it was a slot connected with the new syntax, then we would just call the function pointer. But for slots or when we invoke with strings, then we use static meta call, and we will add, and so the QMetaObject activate, which the signal code would then indirectly call the QStatic meta call on the object on which we want to call the signal. And so in this case, we will give the ID is the ID of the slot we want to run. So say ID 1, we will call set name. And we know that the first element of this array is our string, so we can cast to a string. We know it's a string by construction because we know that we have the right arguments. It has to match between the signals and the slots. So this array of pointer is the one that we constructed in the signal. The arguments are on the stack in the signal stack. And so we call the functions like this. But we can do more than invoking. So this is the continuation of the static meta call. We can do more than invoking function. We can also read and write property. This follows the same idea. When we want to read the name, so this is the property number 0, we can convert. We encode a pointer to the return value in this A array, so we know it's been constructed, it's the right type, so we can reinterpret cast this value into the string and call the getter. And the same for the setter. Yeah, there is also the list of arrays, so the list of byte arrays. So they're constructed with a macros. And as you see, basically, we have only one big string with all the strings are in just one string literal. This is done so to avoid relocation. Every string in the code would be a relocations, and we want to limit those numbers, so we just have one string, and all those qbyte array literal will point to position in these strings. And we have a macro, it's all generated code, so you don't have to to compute yourself those numbers. They're generated by mock. But what it does, it really creates one just big region of memory with all the byte array literals of all the string we need. And finally, this integer array, which contains all the data. And so I'm not going to explain in details what everything does, but we start with a revision, so it's versionized, and then we have, like for example, the numbers. We had one signal, one slot. So, oops, what's happening now? So we had one signal, one slot. So that's 2. So we had, and 14 here is the index in the same array. So that would be here would be the 14th, and then the information about the signal, which of those string it was for the name. So the name of the signal would be the first element of the array, or the name of this slot would be the 4th name of this array. And so all the information is encoded like this in a big integer array, which QMetaObject and QMetaMethod and QMetaProperty are reading this array, and this is how the whole thing works. So if there is any question at this point, it's the time to ask it. So this was basically what mock does, and I hope that if you thought it was magic, that now you understand, and that you see what mock does. And so the question is, do we need mock, or can we get rid of it? And here comes Verdigris. So Verdigris is basically a project. Can we get rid of mock only using macros and template metaprogramming? Because we're in 2019, and C++11 is there, C++17 is there, and people have been claiming that mock was created in the 90s with Qt1. And do we still need mock? And this is basically an experiment to find out if it's possible to get rid of mock. And so this experiment started in 2014. There was a paper that was submitted to the ISO C++ standard that was proposing some ways in C++ to do reflection. And the question is, could this be used to re-implement mock? So I've tried. I generated myself the code that would normally be generated by the compiler, and I did a bit of template metaprogramming and find out, yes, I mean, this could do. This was not enough. There was a lot of things missing, but this is something that could indeed, that we could maybe do mock without having a separate tool. So to do everything just in pure C++. Then in 2015, there was this fork of Qt called CopperSpice. I don't know if you've heard of it. Who here has heard of CopperSpice? Very few people, and that's expected because this is so CopperSpice. They forked Qt 4 and they claimed Qt is really nice, but it's really from the 90s. It's old. We want to do modern C++. We want to use more of the STL and templates, and we do not want to use mock. And so they tried to get rid of mock, and they added some macros and some template metaprogramming, and they did it. So they managed to get a fork of Qt, and with some macros, and then you wouldn't need mock. The problem is that those macros, they are not so pretty, and also the second problem is that it's a fork of Qt, so you would have to port your code to use this. It's a fork of Qt 4, It's maintained by 2 people, so this doesn't really, there is not really a way to compete with Qt itself, so you do not really want to use that. But there are some good ideas, and I thought, oh, I could try to do better. I can try to get inspired by those macros and do the same, but generate the QMetaObject at compile time using const expression and template metaprogramming in a way that is binary compatible with Qt. So just normal Qt, no need to have a fork of Qt, just the normal Qt, but using those macros, you can avoid using the MetaObject compiler mock. The other thing that's another thing that CopperSpice did was that they had a lot of runtime overhead, because every time you run your application, it had to rebuild the MetaObject at runtime. While I wanted really to build the MetaObject at compile time using const expression, so that really what we have is exactly the same as what mock would generate in the final binary, or almost exactly the same. So then what is Verdigris then? It's actually working. It's actually working. We'll see how this works. But it's a header-only library, so just 2 headers. You can put those 2 headers in your repository, or do Git submodule or anything. And it's basically a set of macros that can be used instead of Qt macros. And when you do that, you do not need to run mock. It has some additional features, so we can use it with templated QObject and nested QObject. And one of the downsides, maybe, is that it requires C++14. At the time Verdigris was released, it was 2016, so C++14 was maybe not used, but today, I wonder who here uses C++14 already? And who cannot use C++14 yet? So it's a bit, there's more people that raised their hand the first time. And just out of curiosity, how about C++17? Even some hands for 2017, so not everybody use old technology. So yeah, but at the time, C++14 was maybe a bit too new, but now now years have passed, and that's better. So here's the difference between Qt and Verdigris. So it's basically very similar, but instead of using QObject, you would use WObject and then the name of your class, which you have to repeat in parentheses. You have to repeat the name of the class because we need to instantiate things with the name of the class, which we cannot get without you repeating it. And then outside of the class, so in the CPP file, you have to write WObject impl with your class. So it's a bit more work there, but that's how it is. Then in Qt, when you write a slot, you do public slots, and then you write all your slots. But with Verdigris, you do void my slots, and then you have to register the slot with W slot, and then you repeat the name of the slot. For signals, it's basically the same as for slots. There's a big difference, is that for slots you end with a semicolon, but not for signals. That's because the W signal macro will re-implement the signal itself. So we saw earlier this call to QObject activate. This is going to be in the expansion of the W signal macro. And the other thing is that you need to repeat all the arguments. So you need to repeat the name of the arguments in the signal macros. And property is almost exactly the same as QProperty. The only difference is this semicolon here. So now I've ported the example from the beginning to Verdigris, And there is how it looks. So as we see, it's not so different. In the C++ file, we add this, the W-object imp. But other than that, it's quite similar. Yes, the enum is a bit, could be improved here, as you have to repeat. You have to repeat every name. That's not ideal, but it could be improved. But otherwise, for property and signals and slots, there are some changes, but it's overall not so different. And that's it. And so now you can use this object just like you would use a QObject. It's the same. It's just that mock do not need to be run like this because everything is implemented with templates and macros and const expression. And so one advantage is that you can use template. So you cannot normally do that in Qt without, because the mock would complain, wouldn't want to generate the code for this. But here you can. So the small difference is that you need to tell the macro that it's a template class. But other than that, it looks the same as the previous class. You can also have nested class. It's another small feature which mock won't allow. It works fine with Verdigris. When you have overloads, this is a bit more complicated. So overload in C++, but when you have signals and slots that are overload, maybe you've noticed that this makes it a bit more complicated to call signals and slots, because you also always have to cast to the right type. And those macros, they would have to do the same. So if you want to use overloaded signals or overloaded slots, you need to give the slot macro the list of arguments as a second parameter in parentheses. This is a slight. Yeah, this is not so great, but that's overloads. We probably should avoid them anyway because it's difficult to connect to overloaded signals or to overloaded slots. So we probably should avoid overloads. If you have custom types, so that means types that are not the built-in Qt types, you need to register them to the system. So this is different from QMetaType. It's registering them to the Verdigris system, so you need to use register archetype. If you do not do that, you will get a static assert reminding you that you need to do that. If you use this overload syntax, you also do not need to register the types because that also registers them. So let's look at how this works behind the scene. So this is getting we've seen a lot of code currently, and we're going to see even more. And this is not going to be easy code, but I tried to go not to go too fast. So we are going to need a compile time number. Let's call it this way. So this is just a struct which has a template parameter, which is a number. By default, this number is 255. This is the maximum number of signals or the maximum number of slots you can have in a class. So that's another small problem, that you cannot have a class with more than 255 properties or 255 slots. Anyway, let's look at this number. This number inherits from the previous number. So the number n inherits from the number n minus 1. Of course, we have a special case for 0, so it doesn't go to infinity. So 0 do not inherit from the previous number, but so what we have basically is a number that can be converted. So the number 255 can be converted to the number 254 or 253 until 0. And we're going to use that to build some state. We want to have a state that contains all the signal, all the slots, and so on of the class. So the WObject macro will initialize those states. So the state is represented in a friend const expression function. It could have been a static function too, but there was a bug with one of the compilers, so the static function didn't work, but friend function worked. And so we'll call this WObject macro will initiate both the slot states, the signal states, property states, class info states, all the states will be initialized, and they return, so those function returns a binary tree. So this binary tree object is a bit like a tuple. It's basically a tuple. But the problem with std tuple is that it's not made to be used with huge amount of elements in it. So it compiles very slowly. If you have more than 16 elements in a tuple with some implementation, it just doesn't work. And so let's look at the parameters. We take the number 0 because it's the state is empty, and we have a pointer to the type. So it is a pointer to the type because we want to have a reference to the type there, and we also want to have something that do not convert to anything else. If it was just a pointer to the type, it could convert to a pointer of the derived class, which we don't want. So that's why we have a pointer to the state. Anyway, those functions just empty. They do not really do anything. Whoops. They do not really do anything. So let's look at the other macros. And this is probably the most complicated slide of my presentation. So all those macros, signals, slots, they're gonna append something to the state. So, what does this state append macro work, does, and how does it work? Well, it's gonna, so we're gonna call it with both the slot state and the signal state. In both cases, it's gonna declare a function with the same name. So we've already declared a function with slot state previously in the WObject macro. But what are going to be the arguments of the state? So the second argument will be a pointer to the type. So this this type is the type. It was also declared in the WObject macro. So we have, as before, a pointer to the state, and we also have a number. But which number? Well, we're going to do the type of calling this function with the number 255, and again a pointer to a pointer of this type. So that's the difficult part here. What's going to be the return type of this? We are declaring a function and we're calling it at the same time while declaring it. It's a bit confusing, but we cannot call the function that is currently being declared, so that's going to be the previous function. And since the number 225 converts to all the previous numbers, it's going to take the last number for which we declare this function. And in our case, well, at the beginning, it's going to be 0, and then for the second slot, it's going to be 1, for the third slot, it's going to be 3, and so on. And then we take, so remember it was returning the equivalent of a tuple, and this equivalent of a tuple has a size, and then we add 1 to it. And we have here, so this binary tree we can add. And what do we add to it? Well, the value of our slots. Okay, so everything clear? This slide is not easy. Yeah, but that's basically how we can have states with templates. So then, what is this state? Well, we're just gonna call a meta cons expression function, and we're gonna call it with all the information we need. So here is basically an expansion of this W slot, semi-expanded. So we're gonna declare a new state with a number whose type is whose type is. So we're gonna declare a function of the state, and the arguments will be a pointer to a pointer of this object, and the number, which will be the number depending on the previous state that was declared plus 1, so it's the next one. And then we're gonna call the previous state, and we append the information about here the slots that we wanna call, set name. Okay. We can now build a state. That's basically now we're almost done. So now we can use this state, and then there's a lot of cons expression code that will take this state, generate a list of string, generate this all those integer. It's a lot of code. It's not so much magic, but at the end, what we have is a QMetaObject built completely at compile time. So, who uses Verdigris? I don't know how many users of Verdigris there is, but there are actually users who use Verdigris in production. Because I just know that they're using it because sometimes they're reporting bugs, and I have to fix them, but they actually use it on all compilers, MSVC, GCC, Clang, and they're quite happy with it. So Isotronic is some company who's doing some image recognition software for some industrial software. I don't exactly know what they're doing. But the reason they say they use Verdigris is because it makes the build faster for them. So this is a bit intriguing, because I would think that all these templates and cons expression would be slow to compile. But in the end, one of the problems of mock, they were using CMake before, and CMake had some problems knowing whether or not something had changed, so it was rerunning mock and recompiling too much stuff when they were doing incremental build. And so when they switched to Verdigris, they switched all their code to Verdigris. The incremental build became much faster, and the other thing is that they're using concurrent compiling. They're using a compilation farm, and you cannot parallelize mock runs. While the compiler, we have tools that can run the compiler on many different machines, and so that was the reason why they choose to use Verdigris. And OCSCO is an open source project, so it's on GitHub, and you can look at how a big project that uses Verdigris looks like, and they use it also for compilation time and for also to use template class with QObject. So then, Verdigris is this header-only library. You can just use it in your code. It's LGPL. The macros are a bit more ugly, let's admit it, and that's one of the reasons why I think mock will stay, is that it's still easier to use the macro from mock. So in conclusion, I had two goals in my talk. I was the first goal was to try to explain the way the meta object and mock works, and to just remove the magic if there was some magic. If you didn't know how it works, I hope this is clear now. And my second goal was just to present Verdigris, to show that it exists, and maybe you'll use it if you're interested. So if you have any questions, it's going to be time to ask them. If you don't have time to ask them now, come to me at any time, just talk to me, please, and ask me your questions. I will give the microphone.
Hello. I have just one question. How are the performance of an application that use Verdigris compared to the one that use the normal mock object compiler?
Yes. So, what are the questions at runtime? What is the difference between, performance-wise, between using the macro from the Qt macro or Verdigris macro? And there should be none, because technically, the two should produce the same result. The two should produce the meta object at compile time with the same data. Everything should be the same, so there shouldn't be any differences. The question is how faster does it compile, or how slower does it compile? And this is something some people might or might not be interested. But there is a lot of it is a lot of template code, a lot of macros, and this takes time to compile. But since we do not have to run a tool next to it, this might benefit from the build system that it's just C++ code. And so this might, in some case, be faster or slower depending on how many signals or slots you have. But at runtime, they should be completely equivalent.
Yeah, I was going to ask why a W, because Verdigris does not have a W in the name, but I guess I realize now what it is. Can you just confirm why?
Right, so I didn't know how to name this when I started the project, but so I just used W because it's Wobok, my company. So that's where the W comes from. Then the name came, it's Rich Moore. He was maintaining Qt Network at the time, and I was asking on some IRC channel, so how should I name this competitor of Copper Spice? And then he came with Verdigris, and I thought, oh, okay, Verdigris. So that's what the W stands for, and that's what the name comes from.
I think that in Qt 6, the next version after 5, they are thinking of removing the mock, possibly. So do you know if this is the right path that we'll go through, so that when we move the code, that is still compatible with the new version, or not?
So I do not think, so one of the goals of Qt 6 is to keep as much as source compatibility as possible with Qt 5. So this means, because there are so many millions of lines of code written with Qt 5, Qt 4, and so on, that we do not want to break the old connection syntax. And the old connection syntax needs, well, as we see, it doesn't, but still, the old macros, they still need mock, and therefore, mock will not just go away. Maybe this is going to be deprecated, and new code, and I mean, mock will still exist, but only running for old code. I don't know about that, because nobody knows, because Qt 6 hasn't been, it's still in progress. This decision hasn't been taken yet. Indeed, the question is, should we deprecate those macros? Should we use, let's go back to the slides with the differences. Yeah. What is better? Should we use those macro, or should we prefer those macro? that's another question, and mock has some drawbacks, and we'll have to decide. We'll have to see. So I'm curious what also you think about those macros. How do you like it? Would you mind if the old macro were deprecated and new code should use the new macro? Yeah, that's the community to see.
Hello. Is there any possibility to integrate mock and Verdigris, maybe for small steps refactoring of existing code?
Right, so the question is, if I understand correctly, can we use both at the same time? Can we? And the answer is yes. So you can have, yes, if you run mock over a file that uses Verdigris, mock will say, oh, but there is nothing there. I will just generate nothing. And that's what you want because there is nothing to do. So yes, you can class by class change. So the thing is, one class needs to choose, you need to choose between mock or Verdigris for one class. But for the whole project, yes, you can do class by class, or if you have just one template class, you can use it just for this one template class, or one header which you would use some feature that mock doesn't support. You can also use it just for this one feature because it's really completely compatible. So you can use it. You can use it in addition to mock or just as a replacement to mock. Yes.
Do you have to move the code manually, or there is an automated tool to do it?
So I know that there is somebody who contributed some Python code that with some regular expression that can help you to automatically goes over many classes, and because basically those regex are not so complicated. I guess you could write a sed script that do most of the work. There is no official tool, so there's still some manual tweaking and stuff, but you can go quite far with regular expression to do the replacement. Yeah, but this is yes, there could, but then there could be more automated tools to do the replacement. Yes.
No more? Okay, thank you again.